learn best by doing. They need to represent visually their thoughts and understanding. Children need to visualize what they are learning and their understanding, and the use of manipulatives that aids the consolidation of their thoughts, their understanding, and their visualization. So the manipulatives, I mentioned it earlier, it creates that desire to learn. And manipulatives are the best resource because they can touch them, they can hold them, they can move them. And, you know, and manipulatives that can be made and created by us are even the best way of working with our children. How can I show 23, 2 10s and 3 1s? How can I show 23 using the Numicon? I've got 2 10s and I've got 3 1s as well. So this idea here is a lovely activity sheet that you might want to use, where you give children the number in the middle and they've got to represent it on the piece of paper using the Deans, using the Numicon, and if you want to push them, using the place value counters. So 3 different ways of representing one number. That's amazing. And year 2s can definitely do it. And this is a standalone 5 or 6 minute activity. Can you represent 54? Place value counters, they are round discs, but they're round and they're colored discs. And the ones come on their own. So they got one on the front, and you've got the 10s, which have got 10 on the front, and then you've got the 100s, which have got 100 on the front, the thousands, the tens of thousands, and the hundreds of thousands. And we call them place value counters because it is about place value. You can then represent your numbers using 3 different ways. Children, once again, it's an exciting challenge for them. Can you represent the number 54 in 3 different ways? Something that I do with my year 2s to bring it all together. I've got Numicon, I've got the base 10, I've got my apples, I've got my fruit. So they have to match the number, match the representation to the correct numeral, the correct number. So 12, 12, 7, and 10. A simple activity, but really powerful and really important. Then we've got the 10 frames, but the 10 frames is, as it says in the word, it's a frame, it's got 10 parts, and these colors, they can, when you turn them over, so you might have blue on the other side. So that if you're adding 8 plus 2, you might have 8 red and 2 blues. So these are the frames that children seem to love. They love being able to read the 10 frames, and they can actually physically count the individual circles, or they can move them. They can move them from one 10 frame onto the other 10 frame, and they can turn them upside down to get the 2 different colors. And then I get them to draw their own 10 frames to represent and show me the number. Another activity is to fill in the missing numbers. You know, so I might give them 100 square. I might give them 1 to 20. And I might say to them, well, look, we've got 15. Can you find 15 on the 100 square? Or can you find 15 on the 20 number square? And then what comes after 15? What comes before 17? And then with this one here, we're counting backwards, just to bring an element of challenge and rigor into the lesson. And then this one down here, obviously, according to the children's ability, match the number sentence to the correct answer, to the correct number. So these are just little activities. And this one, add more base 10 to make the number shapes. You know, I've got 54 on the left-hand side. What more can they add to the right-hand side to make the same number? How much did you add in total to make them equal? Some quick fraction work with year 2s and year 3s. Visually, these 2 rectangular bars must be, I'm looking at bar modeling, these 2 rectangular bars must be exactly the same size. And then you ask children to talk about, how have I divided these 2 strips of rectangles into 5 equal parts and into 4 equal parts? What have I done? The 3/4, these pieces are bigger than the 5ths. What does that mean? And, you know, get them talking about, you know, which fraction is bigger, because children will say, well, because you've got bigger pieces here, that it must mean that, you know, the fraction is bigger. That's what it looks like. So I've got 2 out of 5. I've got 3 out of 4. which one has got the most color on it? Well, this one has got the most color. So it tells me that three quarters is bigger than 2/5. As our children become a lot more confident with number, we can start to sort of move, because don't forget, we've got the concrete, we've got the concrete, we've got the pictorial, and then we've got the abstract. So the concrete is what we're looking at now. It's the use of manipulatives, lollipop sticks, pasta shells, whatever. But then when they get to this stage, and obviously year twos can do 8 plus 5 plus 4. And if that is challenging, you can give them eight ones, 5 ones, and 4 ones, or we can use the Numicon to represent each of these. Numicon, for me, would be the best way to do this type of question. But I've done this type of question, and I do this type of question with year twos because they need to be challenged. And when they do their end of key stage 1 SATs, these types of questions, they do come up. And then the more able year twos, they should be able to sort of do 93, take away 65, and so on. And about 4 weeks ago, I was working with some year twos in a school, and they were looking at 3/4 of a number, and we showed it to them using bar modeling, and it was an exciting, interesting lesson.